Ready? Floating and sinking. So now try to be active in this and you have to respond everything. So now let me take one big so we all knows that in our daily life we used to notice these kind of things very clearly. So let me take one container and it is fully filled with water. So now observe very carefully. If it is filled with the water, if I put any kind of thermocol, or you can see any kind of rubber cork or something which is there, then it will start floating or sinking, guys. You might be noticed in our home, you can notice. Yes, if I'll put some kind of thermocol or something in the water, so which is there, water it is, so it will start floating or sinking, all of you?
Floating, sir.
Floating. Okay, is it yes or no? No. If I'll put any kind of iron nail, you might be noticed. If I'll put any kind of iron nail, so that iron nail definitely will go and will settle down at the bottom of the container. Is it yes or no?
Yes, sir.
Yes, sir.
So that is what you can notice it. Now, if this iron nail, if I have been modified into a ship or paper, if I have taken like normal board paper, you might be noticed, or just for example, I am saying, if I make it into this iron, if I will drop into this one into water directly, it will go and will settle at the bottom of the container. But if the same one, if I modified into as a ship or boat or something, then if I'll drop in the water, definitely it will start floating. Is it yes or no, guys? Yes, everybody? Please respond.
Yes, sir.
Are there? No. So let us see what is the phenomena behind how when the object will float, when the object will sink. So that is all we'll discuss in our today's class. That is what principle of flotation. So we know that a cork floats on water, but a iron piece will sink. So if we'll take same way, the same a ship made of iron and steel floats on the same water. A small iron nail will sink, but a ship made with the iron and steel will float on the water. So that is why we should know how does it happen. A small nail cannot able to float, but a ship can able to float on the water. So what is the phenomena behind it? So let us discuss everything. So as we know, whenever an object is placed, from the beginning of this chapter, flotation, we are studying the same thing. Whenever any object is kept inside the liquid, immediately the liquid will start exerting something. What is that? Anybody can tell? Yes, please. Liquid. Whenever an object immersed in the immersed, immediately it will exert something. What is that, guys? All of you. If this is the liquid,
Yes.
if object is partially or completely immersed in the liquid, immediately it will start exerting something. What is that, guys? Liquid. All of you should.
Buoyancy force, sir.
Buoyancy force. That is what I am asking. Do you understanding? Up thrust or upward force. So the force exerted by the liquid is always from top to bottom or bottom to top. All of you, it will act what direction always? Up thrust,
Upward, sir.
upward direction. But as we know, when the object is immersed down, the weight of the object is acting what direction? Weight.
Downward direction.
Weight of the object is acting in the downward direction. That is what you remember. If any object is immersed in the water, so that as we know, the weight of the object is acting downward direction, and from the center you can see the force is acting what direction? Buoyancy force is acting what direction? Up thrust, we can say, is acting upward direction. So all of you should remember the buoyant force or upthrust always acting vertically. What direction, guys? Upwards or downwards? Vertically, upward direction. So let me take that force is called as FB. Buoyancy force is what? Buoyant force, what is that, guys? FB. Now, the weight of the object always act what direction? Everybody, open your mouth. Vertically, what direction, guys? Downward direction. Okay. So buoyancy force by the liquid is upward direction, and weight of the object always will act what direction? Downward direction. So that is what will happen when any object is partially immersed or completely immersed in the liquid. Now, before 2 classes, I have shown you one experiment. You might be noticed if the weight of the object is more, where when the object is in air or when the object is immersed in the liquid. Anybody? Where the weight of the object is more? Anyone?
On air,
In
sir.
air, sir.
That is what we will say real weight. Now, and also I told you, suppose imagine now 1/3 of the object is immersed, and the second beaker if you have taken, now the 2/3 of the object is immersed. Now only this much. Now tell me where the buoyancy force is greater, either this case or this case. Hello?
Sir, in the second case, sir.
Second case. So as we know, the immersed portion, understanding the immersed portion is increases. Immersed portion of body increases, then also it will increase what, Omar? Then buoyant force also increases or decreases? Also
Increases.
yes. So because of that, the weight of the object is decreasing or not? The weight of the object, but
Decrease.
weight of the object is less. Weight of object decreases. Yes, Mitakshri, Harini. Immersed
Yes, sir.
portion is increases. Weight of the object is decreases. That is you should remember. Now, let us discuss. I will say you 3 things. Now, I have given you 3 different objects. Let us consider one object will go and will settle down. So let me draw 3 different containers so that you all can understand. So I have taken 3 different containers. First container, okay, and let me take this is the second container. All are same, okay, and let me take this is the third container, okay. So now you tell me all the 3 cases, very very important, guys, please kindly remember. So as it is 3 containers I have taken, okay. Hari, Mitakshri, Hari Zeras. Now first case I'm drawing, that is also I will draw neatly so that you will understand. So first case, let me take the object is going and settled down. Object went and settled. What happened? It will settle at down. Okay, everybody. Now second case, object is floating on surface. Understand, Hari? So second case, object is floating on surface. Everybody, is it okay? Please respond.
Yes, sir.
This object is floating on surface. Like this, it is floating. Next, third case, just below the liquid. Is it okay, Hari? Mitakshri? Now,
Yes, sir.
these are the 3 cases. Basically, we people will notice when we are seeing any kind of objects in our surroundings. Some objects will settle down, some objects will float on the surface, some objects will float inside the liquid. Is it yes or no? Everybody? Now, let us consider for every object, if I'll take, now in this case, if I'll consider this object, now One force is now also one force is exerting upward direction. What is the force exerting upward direction, all of you?
Buoyancy force, sir.
Buoyant force, FB. Now, one force is exerting downward direction. What is that force, all of you? What is the force? Weight. Okay, weight will represent with a W. FB will represent with what? Buoyant force. Okay, please all of you write. Now, this object also two forces are exerting. What is that, everybody? Harizeras. First one is upward force. What is the upward force? Buoyant force. And downward, this one is, what is that? Weight again. Okay, everybody, please respond. Now, third case, when the object is inside the liquid, it is not settling neither up nor down. So here also one force is acting downward direction and one force is acting upward direction. What is that force called as? Buoyant force is upward and downward is weight of the object. All the three cases understand, everybody? Yes, please. All of you. Now, remember the object floating or sinking or floating inside the liquid means neither surface nor down. Then you remember it is depends on the two forces, that is what? Buoyancy force and weight of the object. Now, first case, if we'll consider case one. So let me consider this is the case one. Is it okay? And this is what, guys? Case two. And this is what? Case three. Now, if we'll consider the case one, all of you should remember, object is sinking or floating. Everybody? Yes, please. Aswin, object is sinking or floating? Object is sinking. So remember, if the weight of the object is greater, please write. If the weight of the object, what is the weight of the object will represent? Harini, weight of the object will represent with the W is greater than, okay, greater than the buoyant force. What is the symbol of buoyant force? Hari, Kaushik, Arun Kailash? FB. Understanding? F small letter is not FB, guys. Okay, it is subscript. Keep it in mind. Subscript it is. FB is the subscript of buoyant force. Okay, then object will sink or float. Then the object will, what will happen, Hari? Will sink or float?
Sink, sir.
Object will sink. Sink in the liquid. Are you understanding? So if you are feeling difficult to write everything, you can write simply weight of the object is greater than buoyant force. Is it okay? Clear? Harizeras, Nimish, Gokul? That is what. Okay. Now, second case. Second case, anybody can tell me what is happening? Who is greater now? Object is floating. So who is greater? Buoyancy force is greater or weight of the object is greater? Completely floating. Everyone? Buoyancy force is greater so that the weight of the object is less. So it will be floating on the surface. Understand? Yes. Next, that is what case 2. So case 2, buoyancy force FB is greater than weight of the object. So that is why in this case, the object will float where, guys? Above the surface or below the surface? Object floats. Understanding? Above the surface. Above the surface of the liquid. Is it okay, all of you? We will study the principle also. What is the principle behind, sir? This one. We will study that. Okay? Surface of the liquid. Please note it down, everyone. Any doubt? Clear? Please respond. That is what it is. Next, third case. Third case, anybody can tell me? That is not coming up, neither coming up nor going down. Means it is floating inside the liquid. Yes, Mr. Gokul, Akilan, Aris, open your mouth and tell me what is happening in this case. It is neither settled down nor coming up. Means the sense of what? All of you, please. When it will be settled, it will not neither coming up nor going down. Means both the densities are what? Both the densities are what?
Same, sir.
Same. That is what it is. So, if understanding buoyancy force is equals to weight of the object, okay, then it will float just below the surface of the liquid. Then object floats just below the surface of the liquid. I hope everybody understand all the three cases. Any doubt? Anyone? Please let me know. Clear? Mitakshri? Harini?
Yes, sir.
Yeah. So very, very important. So all should draw the neatly and make it. So all of you should remember, immersed portion is increases, buoyancy force is increases, but weight of the object is decreases. Now, same way, if the immersed portion is increasing, means the object is going to sink, means the weight of the object is greater than weight of the buoyancy force, so that object will sink. Weight of the object is less than buoyancy force, object will float. Both densities are equal, means buoyancy force is equals to weight of the object, then object will float just below the surface. Is it okay, everybody? Yes, please. All of you?
Yes.
Yeah. So that is what you have to remember. How many of you understand this concept? Any doubt? Anyone? Please let me know. Yes or no? So totally three cases, nothing is there. First case, sinking. Second one is floating above the surface of the liquid. And third case is floating just below the liquid surface. So as it is very important one, kindly remember this, all the three cases. Unless you study this, then your foundation is not great, like we can say up to mark for your higher classes. So that is why this is a very stressed concept. Keep on saying that, to insisting you to study, because as it is a very big chapter in class 11. So kindly remember that. So this foundation should be gone. Now, this is what is floating and sinking. So I think everybody is having a minimum idea of when the object will float, when the object will sink. Is it as Hari Seras? Are you clear? Okay. Please respond, guys. Now, if you understand this, then keep heading. Principle of flotation. Shall we start with that principle of flotation, everyone? Right. Principle of flotation. Now, as I told you, if I put the iron nail in water, is it going to sink or float, guys? Iron nail in water. I want the response from you all. Yes, please. Iron nail in water, it will sink or float?
It will sink, sir.
Sink. Now, if I have taken 2 beakers, everybody, if you want to understand the principle, very important, 3 cases we are having. That is what I am saying. So, first case I have taken water. So, if I put the water iron nail, the iron nail is going to sink. Now, second case I will take mercury. Now, you tell me the same iron nail if I'll put in this. Now, is it iron nail will float or sink?
Floats.
It will float. But here, iron will sink. So only because of one reason. Anybody can tell? Here iron will sink and here iron will float. Yes, Akilan?
Density is high, sir, mercury.
Very good. Here, density of iron, my symbol is what? Rho. Density of iron is greater than density of water. Water means what it is? Liquid. Next, density of mercury, Hg, is greater than density of iron. So that is why iron will float in this case and iron will sink in this case. Is it yes, Hari? Hari,
Yes, sir.
that is one. So please all of you remember that very, very seriously. So that is only the principle of flotation and sinking. So please remember, an object float on a liquid when the buoyant force applied by the liquid balances the weight of the object. So that is only called as principle of flotation. Write it. An object floats on a liquid when the buoyant force applied by the liquid balances weight. Balances the weight of the object. Okay, so that is what we used to say, principle of flotation. So shall we start now, everybody? How to analyze this and how much it is? Yes, sorry. Yes.
Yes, sir.
No. So mathematically we have to prove. Now let consider the object density is. Let consider object density is sigma, because it's confusing. Is it okay? What is the density symbol basically? All of you? Density will represent the d or rho. Okay. Now it's both for one object. So we are having now two objects. One is liquid density, another one is what density? Try to interact. What is what density? One is liquid density, another one is what density? All of you. Object density. Do you understand, everyone? One is liquid density, another one is object density. Now, as I told you, if the liquid is immersed in the object, tell me which surface will experience more buoyancy force, bottom surface or top surface? Force by the liquid. Anyone?
Bottom surface.
Bottom surface. Because depth is more. Yes or no, Hari? Now that is what I am saying. So let's consider object density is sigma. Remember, this is the symbol sigma, and volume is V. Is it any doubt? Anybody? Please let me know. Anybody is having any problem? So let's consider object density is sigma, and volume of the object is how much, Mitaksri? V. Okay, now you tell me, is it completely immersed or partially immersed? I already kept inside. So it is what?
Completely immersed.
Completely immersed. That is also you should remember. So now object is completely immersed inside. I don't know, some Hariseras, what happened today? So completely immersed inside the liquid. Now, let me take the density of the liquid is something. So let density also, liquid also will be present. So density of liquid is D. Is it okay, everybody? Yes, please.
Yes, sir.
Yes.
Let me consider the volume displaced by the liquid is V1. Okay. The object displaces how much volume, Mama? Displaces volume. How much are it? V1. Okay. V1 of liquid. So now let us consider these points. 4 points you should remember. So one is object density is sigma and volume is V, and density of liquid is D, and the liquid displaced by the immersed object is what, guys? What we assumed? Everybody. What we assumed? Everyone should tell. Which is V1. Yes or no, Hari? Yes?
Yes, sir.
Now, can anybody tell me what is the upthrust is equals to here? Upthrust is equals to something we studied before. Yes, Mitakshri? Upthrust is equals to
V1.
Archimedes principle. Archimedes principle, if you know, you can answer. Mr. Omar?
Sir, V1.
No, upthrust is equals to what? Weight of the liquid displaced. That is, please, all of you remember. That is only Archimedes principle. Those who are absent in last class, please remember the upthrust acting on this body, which is equals to weight of the liquid displaced. Is it okay, everybody? Please respond. Weight of the liquid displaced. That is only called as what principle we used to call this one as?
Archimedes.
Archimedes principle. Please remember that. Archimedes principle. Upthrust is equals to weight of the liquid displaced. Now, can you tell me anybody what is the weight formula? All of you should tell me. What is the weight formula? Weight.
Mass into acceleration.
Yes. Mass into acceleration due to gravity. Any doubt? Yes, please. Yes or no? Now, which is equals to, this is upthrust, guys. So upthrust means what? Buoyancy force or any other weight of the object. We're having two things now. This object is experiencing two things. One is buoyancy force in upward direction. Another one is acting one fellow in downward. Who is that? One fellow acting downward. Who is that?
Weight.
Weight. That is, you have to remember. Now we are writing only upward. So upthrust is equals to weight of the liquid displaced, which is what? Mass into acceleration due to gravity. Now, from density, please respond. Density is equals to mass by volume. From that, mass is equals to what, guys?
Density into volume.
Okay. Now, can I write in place of mass? I will write as a density into volume. But here volume means what, Ari? Volume of object or volume of the liquid displaced? Anybody?
Volume of liquid displaced, sir.
Others? Mr. Kaushik? Johan? Volume of liquid displaced or volume of object? We are writing now upthrust means it is done by liquid. So volume of what will come, guys? Volume of the liquid displaced, okay, into G. Now, so what is the density? Density of the liquid, check it. What we assume, density of the liquid? D.
D, sir.
And what is the density of, volume of the liquid? V.
V1.
V1. So the formula will come, upthrust is equals to, what will come, guys? D into V1 into G. Is it as? Everybody?
Yes, sir.
Let me consider this is equation 1. Any doubt? Anybody? Clear? Same way. Weight is equals to, tell me now here. Weight is equals to weight of the object. Weight of the object is also two things. It is a multiple of two things. Anyone? All of you. Weight, downward force. What is that, Hari? Mass of the object. Mass of the object. Yes, Akilan, answer. Everybody try to answer. Girls, Harini, open your mouth. Arun Kailash, into G. So now tell me, what do you mean by mass of the object? Same way here. If I have taken density is equals to mass into, mass of the liquid is equals to density of the liquid into volume of the liquid displaced by that. Same way here. Can you tell me mass of the object means what will come? Everybody?
The density into volume of object, sir.
Yes. It will come density of the object. You want, you can write side. Mass is equals to density into volume. Okay. But here density, what is the density symbol? Object. We assumed as a sigma and V is capital V. So density of object into volume of object. Are you there as understanding? object into G. Now, which is equals to Mitakshri, what is the density of the object symbol? Sigma into volume is V into G. So this is what equation number 2. Any doubt, anyone? Clear? Yes, please. Nobody will say.
Yes, sir.
Yeah. So now we are having, this is the three things. One is upthrust, one is weight. So let us discuss when object will sink. All the three cases I will say now. When the object will float and when the object will float below. So first case, let us take object is sinks. Okay, guys. So you can write upthrust is less than the weight of the object. Upthrust is less than the weight of the object. So object will float or sink. Upthrust is less than the weight of the object. Object will float or sink. All of you. Check.
Sink.
Yes. Object will
Sink.
Sinks.
Yeah, object will sink means buoyancy force is greater than weight of the object. Is it right or wrong? Yes, please.
Yes, sir.
Yeah.
Yes, sir.
Now, buoyancy force. What is the buoyancy force formula? We got it. Check it here. Everybody. D into V1 into G. Yes or no? D into V1 into G is greater than sigma into V into G. Is it yes or no? Everybody? Yes?
Yes, sir.
Yeah. Sorry. Is greater than, buoyancy force is less, but you are not telling me. I kept greater than symbol. Here, less than or greater than? Sinking it is. So buoyancy force is less than. Okay, or I can say weight of the object is greater than buoyancy force. So be very careful. Now, so as we know, in last classes and all, we studied the experiment to study the Archimedes principle. Suppose if liquid displaces, okay, 10 ml of water, then what is the volume of liquid object also? Volume of the object is equals to 10 ml. Is it yes or no?
Yes, sir.
All of you. Suppose if the object displacing 10 cubic centimeter water after immersing, then which is equals to volume of the object. Is it right or wrong? Everybody? Yes, please. Please answer. Yes,
Yes,
or no?
sir.
That is what. So remember, all of you, always the liquid displaced by the immersed portion of the object is equals to total volume of the object. Okay? Right. Okay? Or total weight. You can remember. So liquid displaced by the immersed portion of the object is always is equals to, please remember, volume of the object. Are you clear, everybody? Yes? Abhirami, that is what. Anybody having any doubt, please kindly ask. Aswin, understand Aswin? Okay. So I will say that it will turns into D into V1 into G is less than sigma into V into G. So now GG will get cancelled. As we know, V1 is equals to V. So that is also will get cancelled. So finally, who is remaining?
Density, sir.
Density of the liquid is less than the density of the object. So the object will sink or not? The object sinks if its density is more than the density of the liquid. Is it okay, everybody? Please respond. Any doubt? In this, Hari?
Yes,
Clear?
sir.
Yes, Hari? Next, second case. Upthrust is greater than the weight of the object. Case number 2. Upthrust is greater than the weight of the object. Now tell me, is it will float or sink? Everybody, floating also above surface or below surface? I want to know response from you all. Please.
It will float above the surface, sir.
Float above the surface of the liquid means upthrust is greater. Upthrust is greater than weight. So you can substitute D into V1 into G is greater than sigma into V into G. So now GG will get cancelled. As we know, V1 is equals to V. So we also will get cancelled. Now D is greater than sigma. Sigma means liquid density is greater than object density. So object will float or sink, guys. Everyone. Yes, please.